Imagine waking up tomorrow, and you're an inch taller than you were yesterday. And the day after that, another inch. And the day after that, you can't fit through your own front door. What would actually happen to your body, your bones, your heart, your brain, if you never, ever stopped growing? The answer is stranger and more terrifying than you think. Hey, welcome back. If you're new here, stick around because we explore the wildest what-if questions about biology, science, and the natural world. Today, we're asking a question that sounds simple, but leads us deep into biology, physics, evolution, and even real medical history. What if the human body never stopped growing? We're going to look at what actually controls your growth, what happens when that system breaks down in real life, and then, the fun part, we're going to play this scenario all the way out to its absolutely wild conclusion. If that sounds good to you, hit that like button and subscribe. It genuinely helps this channel more than you know. Now, let's grow. First things first, why do humans stop growing at all? The answer lives in a tiny pea-sized structure at the base of your brain called the pituitary gland. This little powerhouse produces something called human growth hormone, or HGH, which tells your bones, muscles, and organs to grow. Your bones grow from special zones called growth plates, soft, flexible cartilage near the ends of your long bones. During childhood and adolescence, these plates are wide open, soaking up growth hormone like a sponge. But somewhere in your late teens, usually between 16 and 21, something remarkable happens. Your growth plates fuse, they harden into solid bone, and your height is locked in, permanently. So the real question is, what if those plates never fused? What if the hormone kept flowing forever? Here's the thing. This isn't entirely hypothetical. We actually have real-world examples of people whose growth didn't stop, and their stories are both awe-inspiring and heartbreaking. Meet Robert Pershing Wadlow. Born in Alton, Illinois in 1918, Robert had a condition called hyperplasia of the pituitary gland, meaning his pituitary never got the signal to stop pumping out human growth hormone. By age 5, he was already 5 feet 4 inches, taller than most adult men. By age 13, he hit 7 feet 1 inch and was still growing. When Robert Wadlow died in 1940 at just 22 years old, he stood 8 feet 11.1 inches, the tallest confirmed human being in recorded history. He weighed 439 pounds and required leg braces just to walk. His death was caused by a faulty leg brace that created an infection his weakened body couldn't fight off. But even without that, doctors of his era believed he would not have survived much longer. His body was simply too large for itself. Robert's story gives us a chilling preview of what happens when growth goes unchecked. But Robert still stopped eventually. Our thought experiment today asks something even more extreme. What if you never stopped? Not for 22 years, but for 50, 80, a lifetime. Let's play it out. Imagine you hit your late teens, but instead of your growth plates fusing, nothing. They stay wide open. The hormone keeps flowing, you keep growing. Years 1 through 5 of endless growth, you might actually feel okay. Growth is gradual, maybe half an inch to an inch per year. You'd be unusually tall, 7, even 8 feet. Life would be awkward, door frames, cars, standard beds, none of it built for you. But you'd be alive and functional. But here's where the serious problems begin. Your heart. Your heart is a muscle, and like every other organ in your body, it grows too under continuous growth hormone. At first, a larger heart sounds like an advantage, right? More pumping power. But here's the problem. Your heart has to pump blood to an increasingly enormous body. The distance that blood must travel from your heart all the way down to your feet grows longer and longer with every passing year. The heart works harder and harder and harder. Eventually, the heart muscle itself begins to thicken, a condition called cardiomegaly. A thickened heart becomes stiff. It loses its ability to fill and empty efficiently. blood pressure skyrockets, the risk of heart failure, arrhythmia, and sudden cardiac death climbs rapidly. And that's just the heart. Your skeleton would be screaming. Bone is incredibly strong, but it has limits. As your height increases, the compressive force on your lower spine, hips, and knees increases exponentially, not linearly. Engineers call this the square cube law, and it's one of nature's most brutal rules. Here's how it works. If you double in height, your weight doesn't just double, it increases by 8 times, but your bones only get 4 times stronger. That gap? That's where bones snap. By the time you hit 10 or 11 feet tall, your leg bones would be under stress they were never designed to handle. Simple walking could fracture your femur. Standing up from a chair could dislocate a hip. This is precisely why you don't see 15-foot-tall land animals anywhere on Earth today. Evolution has already run this experiment, and the physics always wins. Let's talk about something most people overlook: your nervous system. Right now, when you touch your toe, the signal travels from your toe up your spinal cord to your brain in a fraction of a second. Nerve signals travel at roughly 200 miles per hour, fast but not instant. As you grow taller, those nerve pathways grow longer. At 8 feet, the delay is noticeable but manageable. At 12 feet, at 15 feet, your reaction times would slow down measurably. Your sense of touch in your extremities would become sluggish. Fine motor control, writing, buttoning a shirt, holding a fork would gradually deteriorate. Meanwhile, your skin is stretched to its absolute limit. Skin is elastic, but not infinitely so. Constant, rapid expansion creates stretch marks, not the minor kind, but deep structural tearing of the dermis layer. And here's a truly unsettling one: your face. Continuous growth hormone exposure causes bones in the face, hands, and feet to grow even when you're an adult, in a way that's disproportionate and disfiguring. This is called acromegaly, and it's a real medical condition. The brow ridge thickens, the jaw juts forward, the hands and feet swell to enormous proportions. It's the body's skeleton continuing to respond to hormonal signals that have no off switch.
Now let's talk about something almost comedic but deadly serious: food. The average adult needs roughly 2,000 to 2,500 calories a day. Robert Wadlow reportedly required a massive diet just to maintain his size at 8 feet 11 inches. Now scale that up to 12 feet, 15 feet, 20 feet. Your caloric needs would be staggering, potentially tens of thousands of calories per day just to survive. Your digestive system would need to process food at a rate it was never built for. And here's the dark twist: at a certain point, no amount of eating could keep up. Your body would begin consuming itself, breaking down muscle tissue for energy. You'd be simultaneously the largest and the most malnourished version of yourself. So here's the ultimate question. If nothing stopped you, no injury, no infection, no lack of food, is there a theoretical maximum size a human could reach? The answer, according to physics and biology, is yes, and it's smaller than you'd hope. Most biomechanical researchers agree that a human-shaped bipedal creature walking upright hits a functional ceiling somewhere around 9 to 10 feet before basic locomotion becomes impossible. Beyond that, you wouldn't be walking anymore. You'd be crawling or lying down permanently. Your body weight, unsupported by sufficiently thick bones, would simply crush your joints under gravity. But your organs wouldn't stop. Your heart would keep trying. Your lungs would keep expanding, pressing against a ribcage that can't stretch fast enough. Breathing itself becomes labored, every breath a conscious effort. And ultimately, even before all of this, the brain itself would begin to suffer. The pituitary gland, continuing to grow, would press against surrounding brain tissue. Headaches, vision loss, cognitive changes. The very organ driving all this growth would become the thing that destroys the mind controlling it. Here's what makes this entire scenario so fascinating from an evolutionary standpoint. Your body's ability to stop growing isn't a flaw, it's one of the most elegant solutions biology ever evolved. Nature has experimented with gigantism throughout history. The dinosaurs, some of them, pushed the limits of what land biology could achieve. But even the largest land dinosaurs, like the Argentinosaurus, at over 100 feet long, had to evolve hollow bones and completely different body plans just to manage their own weight. The blue whale, the largest animal ever known to live on Earth, achieves its 100-foot length only because it lives in water, where buoyancy offsets gravity. On land, a blue whale would collapse under its own weight within hours. Humans evolved as upright, bipedal, medium-sized primates. Our body plan is optimized for exactly the size we are. Growth stops not because biology gave up, but because biology solved the problem.
So let's bring it all together. If you never stopped growing, here's what would actually happen. Your growth plates would stay open, driven by relentless growth hormone from an overactive pituitary gland. Your bones would grow longer, but the square-cubed law means they'd crack and fracture long before you reached mythical heights. Your heart would enlarge and eventually fail, overwhelmed by the demand of pumping blood to an impossibly large frame. Your nervous system would slow down, signals taking longer, reflexes dulling, fine motor control fading away. Your face and extremities would distort through acromegaly, your skeleton reshaping in unrecognizable ways. And your brain, the very control center of all of this, would be compressed and damaged by the growing gland responsible for it all. The real-world ceiling for a human body walking upright? Somewhere just past 9 feet. Everything beyond that is the territory of collapse, failure, and ultimately, death. But here's my favorite takeaway from all of this. We often look at limits as negatives. We stop growing and we call it aging. We see boundaries and wish we could push past them. But every limit your body has is the result of millions of years of evolutionary problem solving. Your growth stopping at 18 or 20 years old isn't biology failing you, it's biology protecting you. It's an exquisitely tuned system arriving at an answer that took eons to calculate. You are, right now, exactly the right size for the world you evolved in. That's kind of remarkable when you think about it. If you made it to the end, thank you, genuinely. If you enjoyed this one, smash that like button, subscribe if you haven't already, and turn on notifications so you never miss a new video. And here's your comment question for today. If you could choose to keep growing forever, would you? And how tall would you go before you'd want to stop? Drop your answer down below. I read every single one. I'll see you in the next one. Stay curious.